Fifth grade bilingual class. TEKS 5.6c. Force, motion, and energy. The student knows that energy occurs in many forms and can be observed in cycles, patterns, and systems. The student is expected to C. Demonstrate that light travels in a straight line until it strikes an object or travels through one medium to another, and demonstrate that light can be reflected, such as the use of mirrors or other shiny surfaces, and refracted, such as the appearance of an object when observed through water. English Language Proficiency Standards. Cross-curricular second language acquisition reading. 4J. Demonstrate English comprehension and expand reading skills by employing inferential skills such as predicting, making connections between ideas, drawing inferences and conclusions from text and graphic sources, and finding supporting text evidence commensurate with content area needs. As an introduction, the students were asked to see what happens to the toys when one tries to move them with a straw in a tub full of water. This was done to prove the concrete operational stage that states. They begin to understand the concept of conservation. The amount of liquid in a short white cup is equal to that in a tall, skinny glass. Thinking becomes more logical and organized, but still very concrete. Begin using inductive logic or reasoning from specific information to a general principle.
What is it? Fast. It's really fast, right? But what happens when you put an object between? It can't pass through. Sometimes it can go through. It depends if it's clear, right? It can bounce off. Like a mirror, exactly. And what is that called? Do you know? Oh, reflection. Good job. Okay. And what else can it do? It can make shadows. It can bend, just like what happened here. It can bend. Talk to your partner and explain to them how light moves and how it can how refraction affects it.
The science guy.
This magnifying glass is making my eye look big. Now, why is that? Please consider the following. When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other?
Video with what we talked about, what we saw. What is refraction? Okay? Don't tell me. I want you to write it down. Okay? Then you're going to write characteristics. What is it? What is it that refraction has to have? Why? How do you know it's refraction? And maybe not. And then down here, you're going to write an example of refraction. You're going to write 3 here. What are non-examples? What is not a refraction? Okay? Some of y'all mentioned it before. The captain's going to pour water in there. But I want everybody else to, you're going to stand up and you're going to be looking at the penny. What happens to the penny? What's going on with the penny as you put water in it?
I know why you choose white.
And then I will give you a straw and I want you to see what. Put it back in the middle. Okay. And I want you to see, I'm going to give you a straw and I want you to see what happens to the straw. And I want you to draw it as an example, or you can, as a characteristic, you can see what's going on and then you can write that down. Okay? Y'all got it? Let's pour the water. Okay, so you can see what's going on when we look at it. Okay. Okay, now remember, what are you going to be looking at? You're going to look to eye level. Do you see it? What's going on with it? Okay. Y'all stand up. You're going to get a straw, and then you're going to put the straw inside the water. And you can direction, or what's another word? Just straight through, because it's pretty fast. But since it's slow, it's going to... It has to bend. What else? It magnifies it. There you go. That's